press the bell icon on the YouTube app and never miss another update.
Hello students, in the last class we discussed intervals with respect to the real numbers. Yes, na? Today we discuss the one more concept. It is a very important concept. The concept is power set. Very important. In annual examination, so it may ask in 1 marks, define power set. Very important, define power set. So power set means what? Before we define the definition, we write one example. Okay, na? Then only we understand. Let A is equal to 1, 2, 3. Okay, A is equal to 1, 2, 3. So we write the subsets, number of subsets with respect to the set A. The first one, empty set is a subset of A. Yes, na? Last class I discussed this concept. We accept empty set is subset for all sets. First one is. Second one, I take only one element. 1 is a subset of A. Yes. So 1 is belongs to A. 1 is also a subset of A. Third one, 2 is a subset of A. The set contain only one element, 2. It is also present in A, no doubt. 2 is also a subset of A. Fourth one, 3 is a subset of A. Correct? 3 is subset of A. We write the number of subsets. Number of subsets. So next what I take? I take 1, 2. This set is also a subset of A. Yes, it contains 2 elements. Here these are all contains 1 element. And sixth one, I take one more set. The element containing 1 and 3. 1, 3. It is also a subset of A. Correct? So 1, 3 present in A also. So one more I take seventh one. 2, 3. 2, 3. That is also a subset of A. Observe here. 2, 3 is also present in A. And eighth one. One more I write. 1, 2, 3 is subset of A. 1, 2, 3 is subset of A. That is A is subset of A itself. That also we discussed in the last class. Every set A is subset to itself. Correct? Every set is subset to itself. See, observe here. These are all what? These are all the collection of subsets. Correct, na? Subsets with respect to A. What we write? All these. What we write by empty set contain only one element, 2 element, 3 element, 1, 2, 1, 3. All these sets, collection of sets, are nothing but the subsets of the given set A. Correct, na? The subsets of the given set A. This collection is called power set. This collection is called what? Power set. This collection is called power set. So I think you understand. Power set means what? Now I define the definition. Power set, a collection of subsets. A collection of subsets of a set A. A collection of subsets of a set A is called what? Power set. A collection of subsets of a set A or B or C, whatever it may be, a collection of subsets. See, observe here, these are all nothing but the collection of subset with respect to the set A. So, all these collection we call it as what? Power set. The collection of subsets of a set A is called what? Power set. Very important definition. Power set means it is nothing but a collection of subsets of a set A is called power set. So, power set is denoted by power set. Next line, power set is denoted by P of A. Power set. Always remember, very important, power set is denoted by what? P of A. For example, A is equal to 1, 2, 3. Then we write right here, then we write power set P of A. It is also a set. Observe here, power set. See, observe here, power set. So we write all the elements within a pair of curly brackets. Okay, P of A is equal to what? 1, 2, 3. P of A is equal to, first one is empty set. First one is over. Second one, the element contain 1. Third one, the element contain 2, means collection of subsets. All these are all subsets. So 3, next one 1 comma 2, next one 1 comma 3, correct, 1 comma 3, the next one 2 comma 3, 1 comma 3, next one 2 comma 3, 2 comma 3, and the last one 1, 2, 3. 1, 2, 3. Observe here. So all these are all collection of what? The subsets. So power set means it's a collection of subsets. Each element in P of A, very important concept. Each element in P of A in power set are set. Okay now. So this is also a set. This is also a set. 3 is also a set. Each element, this is very important point. Each element in P of A, in power of a set A, are nothing but a set. So these are all subsets with respect to the set A. So these elements are nothing but what? It is a set. Clear? So power set means it is a collection of subsets of a set A. So power set is denoted by what? P of A. So each element in P of A, very important point. Once again I say that each element in P of A are nothing but what? A set. So 1 comma 2, this is also a set, this is also a set, and this is also a set, this is also a set. Clear? So this is very important concept. Define power set. A collection of subsets of a set A is called power set. Power set is denoted by P of A. If you want, we write one more example. So very important concept this one is. So I take one more example. Just I write set A is equal to only 2 elements, A comma B. Write the subsets. Subsets are empty set is a subset of A. Contain only one element, it is a subset of A. Contain only one element, that is B, is also a subset of A, and A comma B. Then P of A is equal to what? Empty set, A itself, B itself, and A comma B. P of A. Understand? Very important point. One more point I explain by using this example. So here N of A. N of A means what, sir? Yes, now this is one new concept. N of A means n indicates the number of elements in A. N of A means what? The number of elements. The number of elements in A. The number of elements in A is 2. Suppose I write one more set, B is equal to 1, 3, 4, 7, 0. Okay now? So n of B. N of B means the number of elements in the B set. Number of elements, what are those? 1, 2, 3, 4, 5. N of B is 5. Understand? So n of A is what? 2. Number of subsets 1, 2, 3, 4, 5. Correct now? 1, 2, 3, 4. Sorry, this is not 5. 1, 2, 3, 4. Number of subsets, how much? Number of subsets. Number of subsets is 4. Correct. Number of subsets. So n of P of A. N of A means number of elements in A. N of P of A means number of elements. Understand? Very important. Number of element present in P of A. Understand? Number of elements present in P of A. How much elements are present? 1, 2, 3, 4. 1, 2, 3, 4. This can be written as 2 square. This can be written as 2 square. Correct now? 2 into. This 2 I can written as n of A. Observe here. N of A is equal to what? 2. So number of elements. This is very important. Observe carefully. Number of elements in P of A is always equal to number of elements in what? P of A is always equal to 2 to the power n of A. 2 to the power n of A. N of A is what? N of A is number of elements in set A. Once again I say that number of elements in P of A. Number of elements in P of A is always equal to. Very important. Is always equal to what? 2 to the power n of A. If you want one more example, I want to write. So observe here. We write one more example. Just previous example. What we discuss? Power set. A is equal to A, B, C. N of A. N of A is how much? N of A is 3. Correct? So we write P of A set. In P of A set, each element are nothing but what? Set. Empty set. First one is over. So a set containing single elements are there. It is also a subset of A. The set containing single element B is also a subset of A. The set containing C is also a subset of A. 2 elements are there. A comma B. Then B comma C, then A comma C, A comma C. One more I write below. Okay, so A, B, C. Set is over. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. So n of P of A. N of P of A is how much? 8. Number of elements present in P of A. Correct now? Number of elements present in P of A is what? 8. So this I can written as 2 to the power 3. Yes now? 2 to the power 3 is how much? 8. Why I write 3? N of A is what? 3. So n of P of A is always equal to 2 to the power n of A. This is very important. N of P of A. This is a formula. Number of elements. Observe the result. Number of elements in P of A is always equal to 2 to the power n of A. 2 2 to the power n of a. This is one formula. The number of elements in P of A is always equal to what? 2 to the power n of a. This is regarding what? The power set. Once again I say that power set means very important concept. It means it's a collection of what? Subsets. Each element in the power set are nothing but set. Here they are elements. In P of A, each elements are nothing but what? The set elements. Set. It is also a set. Then a set containing one more, very important. See, observe here. This is a set. We write in a pair of curly bracket, and this is also a set, and this is also a set. So in each in the given example, the elements are 1. Observe here, it contains only what? One element. This set particularly we call it as singleton set. Singleton set. Singleton set. Singleton set means what, sir? A set contains only one element. Singleton set means a set contains only one element. Only one element. Singleton set. Singleton set means one more. Simple concept. Singleton set means a set contains what? Only one element. See, observe here. This set contains only one element. This set contains only one element. This set contains only element. All these are nothing but what? Singleton set. Okay now? So n of P of A. N of P of A is nothing but 2 to the power n of A. Clear? This is regarding what? The power set. Understand? Okay. Next concept. Universal set. The word says that universe, big set. Universal set means it is a big set. I explain a simple man, big set. Universe, word says that universe. That's why universal set means it is a big set. It is a big set. Then it contains number of subsets. Universal set is a big set. Universal set is a big set. Then it contains what? The number of subsets. It contains what? The number of subsets. Next, one more concept. Universal sets are denoted by U. Always, remember, always universal sets are denoted by U. One example if you want. I take what? U is equal to set of natural numbers. Set of natural numbers. That means U is equal to 1, 2, 3, 4, 5, like that. Then I write subsets. A, just write 1, 2, 3. B, just write 3, 4. C, just write 1, 3, 5. D, just write 2, 4, 6, etc. We write what? We write the number of subsets with respect to the natural number. That's why we call it as this one. We call it as what? Universal set. So the concept is very important. Universal set means it is a big set. It is a big set. It contains what? The number of subsets. It contains what? The number of subsets. And one more, universal sets are always denoted by U. Universal sets are always denoted by what? U. Is it clear? Okay. So we solve the exercise 1.3. So exercise 1.3, first main. First main, make correct statements. Make correct statements by filling in the symbol subset are not subset. Subset are not subset in the blank space. Spaces. First question. 2, 3, 4. He has given one set. Dash. 1, 2, 3, 4, 5. 2, 3, 4. Dash. 1, 2, 3, 4, 5. We have to fill whether it is a subset or not. Just subset or not. See, observe here. This set I call it as A. If you want, and this set I call it as B. We check that all the element present. Subset means what? If A is a subset of B, all the element present in A are also present in B. 2 is present, yes. 3 is present, yes. 4 is present, yes. No doubt. A is a subset of B. Here we fill subset. Understand? Here we fill subset. Question number 2. Second question. X such that X is a student. X such that X is a student of class 11. Class 11 of your school. So he has given dash right below dash. One more set. X such that X student of your school. Of your school. X such that X student of your school. See, observe here. So in school means it contains first standard, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, LKG, UKG, playgroup. That means, so in that, this is nothing but a part of this one. This is nothing but a part of this one means it is also a subset of school. Yes, class 11 is a subset of, means the student of class 11 is a subset of student of our school. Correct? Third question. A, B, C dash B, C, D. A, B, C dash B, C, D. So A is present here? No. A is not present. Suppose this one I call it as A and this one I call it as B. The set A in A, but it is not in B. So that's why all elements in A are not in B, that's why it is not a what, a subset. Correct na? It is not a subset. Fourth question. Fourth one. X such that X is a circle. X is a circle in the plane. In the plane dash right below. X such that X is a circle in the same plane with radius, very important, radius 1 unit, with radius 1 unit. So observe this set first. X such that X is a circle in the plane. X is a circle in the plane means the circle of radius is 1 unit or 2 or 3 or 4 goes on. This is a circle in the plane. This is nothing but A set if I call it as. B set, what he say that X such that X is a circle in the same plane, one more he has given, of radius 1 units, means it contains a circles, number of circles of radius 1 units, and this one contains a number of circles of radius maybe 1, radius 2, radius 3 goes on. So by seeing these two sets, no doubt it is not a subset. Yes, not, it is not a subset of this set. Next problem. Fifth one, X such that X is a triangle. X is a triangle in a plane. X is a triangle in a plane dash. X such that X is a rectangle. Rectangle in the plane. In the plane. So X is a triangle in the plane means it contains 3 sides. It contains 3 sides. X is a rectangle in a plane means it contains how many sides? 4 sides. So no doubt, is it a subset? No, it is not a subset. Sixth question. X such that X is an equilateral triangle. Equilateral triangle in a plane. Dash. Right below. X such that X is a triangle in the same plane. X such that X is a triangle in the same planes. So triangle means it contains equilateral, right angle triangle, isosceles triangle goes on. So the first set particularly equilateral triangle, and the second set it may be all triangles, equilateral, isosceles, right angle triangle, no doubt it is a subset. Correct? It is a subset. Seventh question. X such that X is an even natural number. Even natural number. Yes, I write below. X such that X is an integer. Integer is nothing but it contains negative numbers, 0 as well as positive numbers. Positive numbers means natural numbers. So no doubt it is a subset. Correct na? It is a subset. This completes first main. I think you understand the concept. This what it says to understand the concept of subset. Second main is there, same type of concept. I left to you same concept what we discussed this first main, same concept. It will be repeated whether true or false that he asked. So I left with you. So we take third main problems. Third main, let A is equal to, he has given a set containing the element 1, 2, very important question, 3, 4, this is also an element, okay, this is also an element, 5. Which of the, very important question, which of the following statements are incorrect and why? So, which of the following statements are incorrect? Why? So, he has given first one, 3, 4, subset of A. Second, we write all these things first. 3, 4 belongs to A. Third one, 2 curly brackets, subset of A. Fourth one, 1 belongs to A. Fifth one, 1 subset of A. Sixth one, 1, 2, 5 subset of A. Seventh one, 1, 2, 5 belongs to A. Eighth one, 1, 2, 3 subset of A. Ninth one, 5 belongs to A. 10th one, 5 subset of A. 11th one of A. Observe very carefully. This is very important concept. These are all the question he has given. He has given a set. What he asked? Which of the following statements are incorrect? These are all the statements he has given. Which of the following statements are incorrect? Firstly, what we do? We write the elements. We write what? The elements. elements of set A are. What are those elements? 1. This is also an element. This is also an element, comma 2. This is also an element, and this is also an element because it is present in the given set A. This is also an element, and 5. The elements are, total number of elements is how much? N of A. 1, 2, 3, 4. N of A is 4. This is very important. The elements of set A are 1, 2, and this whole set, pair of curly bracket 3, 4. That is also an element, not a set. Not a set. It is also an element. 5 is also an element. Okay. So first question. Observe here. Observe carefully the first question. 3, 4 is a subset of A. This is nothing but what? A set. It may be B. Yes, if I represent the elements in a pair of curly brackets, if I represent the elements in a pair of curly bracket, this is nothing but what? The set. Set B is a subset of A. See, observe here, 3, 4 element present in A. This is one element. This is one element. Okay. These two are two elements. See, observe, first question. 3, 4 is a subset of A. Is it correct or incorrect? So 3 is present here? No. This is one element. We cannot say 3, 4, these two are same. These are two elements. This complete is one element. Okay. So 3 is present here? No. 1, 2 is present, and this whole element we call it as 0. Okay, now whole element we call it as O, not 0, O. 1, 2, O and 5 is present. 3 is present, observe here, O is present, 3 is not present. 4 is no. So, is it correct or incorrect? Incorrect. It is incorrect because it is a set. Once again I say that this 3, 4 is a set, and this is O. It is an element. This is an one element. This is a set containing two elements. A set containing two elements. So it is not a subset of A. Second one. So it is incorrect. So it is incorrect. This one is over. 3, 4 belongs to A. So belongs to A means it is a member of the given set A. Yes. O, this complete element we call it as O. O belongs to A. Understand? O belongs to A. O now one element is there. So 3, 4, 3, 4. O is element is there. So 3, 4 belongs to A. It is correct. It is correct. Here it is set. Here it is element. Here this one we treated as set. And here it is this one is treated as element. So, element. Yes. O is an element, belongs to A. O is an element, belongs to A. Here 3, 4 is a set, does not belongs to A. So it is correct. Second one is over. Then one more he is written, third one. Third one. So he has written, this is an element O. This is an element O. Yes, O element. This set we call it as what? Singleton set. Singleton set. Because this complete set contains only one element. The element is O. Is a subset of A. Yes. O is an element present here. O is an element present here. O is what? 3, 4. Correct now? O is what? 3, 4. So it is a subset of A. No doubt. It is correct. Understand? It is correct because the element 3, 4. The element 3, 4 present in A set. If you write a reason, so write this. The element 3, 4 is present in A set. That's why it is a correct. Next, third question is over. Third one is over. Alright, here only. Third one is over. Fourth question. 1 belongs to A. Yes, no doubt it is an element. Correct. 1 belongs to A because it is correct. Correct. One subset of A. If I write subset, so we write like this. Then only it is a set. What he has given? He has given only one element. It is not a set. It is not a set. That's why it is incorrect. These two are over. 1, 2, 5. He has given a set 1, 2, 5. Is a subset of A. Observe here. 1 is also present, 2 is also present, 5 is also present. So this is a set containing 3 elements. It is a set containing 3 elements 1, 2, 5. 1, 2, 5. No doubt it is a subset of A. It is correct. Correct. This one is over. So one same question what he has. 1, 2, 5 belongs to A. Here it is a set. Here if belongs means it is an element. The element 3, 4 is present. That be treated as O. But the element 1, 2, 5 present here? No. It is incorrect. It is incorrect. So this one is also over. 1, 2, 3. 1, 2, 3. Subset of A. 1, 2, 3. 1, 2, 3. Subset of A. So means the set contain one element present here. 2 is present, but 3 is not present. 3, 4 is one element O. Since 3 does not belongs to A. 3 does not belongs to A. That's why it is what? Incorrect. If 3 belongs to A, if instead of one more if I write 3, then only it is correct. Okay na? Then only it is correct. Next. This one is also over. Empty belongs to A. If I write belongs, it is an element. Here empty is there. If I write empty here, then only it is correct. Empty is not there. That's why it is incorrect. That's why it is what? Incorrect. This one is over. Empty subset of A. Yes. So we agree this. Empty set is subset of all sets. It is correct. It is correct. This one is also over. The element empty is a subset of A. So when I write like this is an element. Here is present. The elements are 1, 2, O and 5. Empty is not present. That's why it is incorrect. Understand? That's why it is incorrect. All the questions are completed. Second main, all the questions are completed. So very important concept. We go for third main questions. Fourth main, write down all the subsets. Write down all the subsets of the following sets. Following sets. First question. First question, write down the what? Write down the subsets, all subsets of the following sets. He has given only one element. So, solution. Let we write A is equal to A. N of A is equal to 1. Singleton set. So, the subsets are, first one is empty set is a subset of A, correct na? Second one is A because it contains only one element, or if you want to write like this also, set of the number of subsets with respect to the given set is 2. One is empty set, another one is the set itself. What he asked, write down all the subsets. All the subsets of the given set is empty set and set itself. Understand? First question is over. Second question, A comma B. Second question, A comma B. Solution. Let A is equal to A comma B. N of A is what? 2. The number of elements present in A. N of A is what? 2. Correct? Okay. The subsets are first one is empty set is a subset of A. Second one is the set itself, A comma B, is a subset of A. The set itself is a subset of A. Third one, we write one more set containing only single element A. He is also a subset of A. Fourth one, we contain only one element, that is B, is also a subset of A. Correct na? So the number of subsets are empty set itself, set containing single element, that is A, and set containing single element, that is B. Correct? Okay. Third question. Question number 3. Set containing 3 elements. 1, 2, 3. Set containing 3 elements. Observe here. Let A is equal to 1, 2, 3. The subsets are, first one is empty set is a subset of A. Second one, the set itself means 1, 2, 3 is a subset of A, or A is a subset of A itself. Over, 2 over. So next what we do, we write only single elements are there. 1 is a subset of A. Fourth one is 2 is a subset of A. Fifth one is 3 is a subset of A. Set containing single element is over. Sixth one, set containing 2 elements, 1 comma 2. No doubt it is a subset of A. Seventh one, 1 comma 3 is a subset of A. Eighth one, 2 comma 3 is a subset of A. 2 comma 3 is a subset of A. So the subsets are, so up to by set itself, single elements, 2 elements. Total number is 8. Total number is 8. Understand? Fourth question. He has given empty set. The subsets are only one. Empty set is a subset of empty. The subsets are empty set is a subset of what? Empty set. Correct now? Only one side. Correct? Understand? The fourth main questions are over. Next main. Fifth question. How many elements has P of A if A is equal to empty? How many elements as P of A if A is equal to empty? Just now we write P of A means what? The collection of subsets. The collection of subsets. What he has given? Given A is equal to empty. A is equal to empty means n of A is only one element. That n of A element is what? 0. Empty set means a set containing no elements. Empty set means a set containing no element. That's why n of A is 0. Now how many elements of P of A? We know that n of P of A, correct na, is equal to 2 to the power n of A. Just now we discuss. N of P of A is equal to the power n of A. That implies 2 to the power 0. 2 to the power 0 is how much? 1. So that implies the elements present in P of A is 1. That is n of P of A is equal to 1. n of P of A is equal to what? 1. Understand? So very important concept. N of P of A is equal to 1. Next question. Sixth one. Write the following as intervals. First question. X such that X belongs to R. X is greater than minus 4, less than or equal to 6. X such that X belongs to R. X is greater than minus 4, less than or equal to 6. We discussed in the last class intervals. So X greater than minus 4 means this is exclude. X less than or equal to 6 means this must be included. So the solution. Write the following as an intervals. So the solution is minus 4 is excluded means we write what? Open bracket. We write open bracket. Minus 4 comma 6 include means we write closed bracket. Correct now? If I write closed bracket, the element is included. If I write open bracket, the element is excluded. So second question. X such that X belongs to R. X greater than minus 12, less than minus 10. greater than minus 12, less than minus 10. So we have to write in between minus 12 and minus 10. So you know the answer. X greater than minus 12. Minus 12 is excluded. Minus 12, comma. Less than minus 10. Minus 10 is also excluded. That means this interval is called what? Open interval. This one we call it as half open interval. We discussed in the previous class half open interval. This one we call it as the definition of the open interval. Third question. X such that x belongs to R. X greater than or equal to 0, less than 7. X greater than or equal to 0. Observe the problem. X such that x belongs to R. X greater than or equal to 0 means 0 is included. Less than 7 means 7 is excluded. Solution. Answer is 0 is included means 0 square bracket, comma. 7 is excluded means open bracket. This one we call it as half open, same, or one more word, half closed interval. Half closed interval. Half closed interval. Fourth question. X such that x belongs to R, comma, x greater than or equal to 3, less than or equal to 4. Greater than or equal to 3, less than or equal to 4. That means end points are included. Here end point is excluded. Here also end point is excluded. Here the end point is included. Here the end point is included and end point is excluded. But here end points are included. Solution. You know this one also. According to the definition of closed interval 3, 4. This we call it as what? The definition of closed interval. See, write the following in terms of intervals. All these we call it as what? Intervals. So he has given in set builder form. He has given in what? Set builder form. So we write in terms of what? Intervals. If I write intervals, these two elements are belongs to R. Once again I explain, these two elements are belongs to R and first element is less than second element. If I write open interval, end points, here what? End points are excluded. If I write closed interval, end points are included. For A comma B, x greater than A, less than B. Correct now? For this open interval is x greater than A, less than B. For closed interval, x greater than or equal to A, less than or equal to B. X greater than or equal to A, less than or equal to what? B. Understand? This is very important for one more question. Suppose he has given in the set builder form, so he asked the intervals. Next main questions. Seventh main, write the following intervals in set builder form. First problem. -3, 0. In previous problems, He has given in set builder form. We write the intervals. Here he has given in intervals form. What we write? We write in set builder form. Minus 3 comma 4. This given interval is what? Open interval. Open interval. So solution. X such that x is greater than minus 3 because end points are not included. Greater than minus 3, less than 0. Understand? One more question. X such that x greater than minus 3, less than 0. Next question. Six comma 12. This we call it as what? Closed interval. Closed interval. Solution. X such that x is greater than or equal to 6, less than or equal to 12 because 6 and 12 end points are what? Included. Third question. 6 comma 12. Observe carefully. Half open interval or half closed interval. 6 is excluded, 12 is included. Half open interval or else half closed interval. Solution. X such that 6 is excluded means greater than 6. 12 is included, less than or equal to 12. Fourth question. Minus 23 comma 5. Minus 23 comma 5 means this one is also half open interval or half closed interval. Whatever may be. Of closed interval. Observe here, minus 23 is included, 5 is excluded. Solution. X such that x is greater than or equal to minus 23, less than 5. Greater than or equal to minus 23, less than 5. Understand? So very important concept this one is. So in the previous problems, what he has given? He has given in set builder form. We write the intervals. In this problem, he has given in intervals form. What we do? We write in the set builder form. Understand? This is very important concept. Okay. So up to 7th when we finish up, the remaining problems we discuss in the next class. Thank you.